Hello everyone, I'm Mr. Furlong, and today we're going to take a look at how the environment affects enzymes. Enzymes are proteins, and we know that in order for a protein to work properly, it has to have the right structure. If there's a change in the structure, that can result in a loss of function. Since enzymes are proteins, they also have a unique shape that allows them to do their job. If there is a change in the shape of the protein, that is called denaturing. And we're going to take a look at some ways in which proteins can become denatured, and specifically look at enzymes today. So denaturation can be caused by environmental factors, and typically this is irreversible. Now there's a few cases where it can revert back to its original shape, but for the most part, just think if the enzyme has been denatured, it's not going to work ever again. Some of these environmental factors are temperature and pH. Let's look at temperature and how that can affect an enzyme activity. Now the optimal range is the temperatures at which the enzyme will work best in. So for instance, if we take a look at this graph, this enzyme works best at a temperature of about 65 degrees Celsius. That's the optimum temperature. That is the temperature at which the reactions are happening at their fastest. And any temperatures within a few degrees of that is still at its optimum. So hence we can get a range. Now why is this? Well, let's take a look at what this graph is showing. In part one of this graph, that as the temperature is increasing, the reaction rates tend to increase. Now, this is a result of increased collisions. Remember, molecules are constantly moving. The warmer the temperature, the faster they're moving. Enzymes and substrates have to find one another, and they kind of find themselves by accident. So the faster that these molecules are moving, the more collisions that take place, the more often enzymes will find the substrates. Now, as the temperature does continue to increase, however, it doesn't continue to go up because the enzymes will become denatured. And as the enzymes become denatured, the reaction rates fall. And you can see it at step 3. Once those enzymes start to denature, the rate of reaction decreases very quickly, all the way down to 0. Now let's say we go back in the other direction. Let's say that it gets colder. If temperature decreases, the reaction rates will decrease because there's fewer collisions. Makes sense, right? I hope so. Enzymes are not denatured, though, in the cold temperatures. So when we started out at 0 degrees Celsius, it wasn't because the enzymes were denatured. It's just because there's not a whole lot of movement in those molecules. Now, pH is another environmental factor that can alter the enzyme activity. Remember that pH measures the concentration of hydrogen ions. We measure it on a scale of 0 to 14. Anything below 7 is acidic. Anything above 7 is basic. The more hydrogen ions that a substance has, the lower the pH, the more acidic it's going to be. Now remember, pH is also based on the power of 10, which means that an item with a pH of 5 is going to be 10 times of a stronger acid than something at a pH of 6. So for instance, in this example here, coffee is at a pH of 5, milk is at a pH of 6. Coffee is 10 times of a stronger acid than milk is. But what's happening? The hydrogen ions can actually disrupt the hydrogen bonds in amino acids. Now, this will then cause denaturation and a decrease in the enzyme activity. But that's not true for every single enzyme. So for instance, lipase is an enzyme found in our small intestine. It breaks down lipids. In the small intestines, it likes to have a basic pH in order to work. The optimum pH for lipase is right around 7.5 to 8. But pepsin, which is an enzyme that breaks down proteins in our stomach, likes to have a really low pH. It likes to be somewhere around 2 to 3, which is why our stomach produces acids. That enzyme works really well in a low pH environment. If we put it into a higher pH, we'll see some denaturation and a decrease in enzyme activity. If you take lipase and put it into an acidic environment, you're going to have some disruption of hydrogen bonds, some denaturation, and a decrease in enzyme activity. Another environmental influence is the concentration of substances and products which can affect enzyme activity. So for instance, let's start with substrates. Let's say we have a whole bunch of substrates. Initially, the enzyme activity will increase. There's a lot of substrates that the enzymes can work on. But as the number of products increase, the enzymes are going to have a harder time finding those substrates. And so eventually, the reaction rate is going to even out, and then eventually it'll decrease because there won't be any substrates left for the enzymes to react with. There are other chemicals, though, that can inhibit enzyme activity. One type is called a competitive inhibitor. Now take a really good look at this picture. Look at the substrate and the inhibitor. They both have a part of their structure that allows them to fit into the active site of the enzyme. Now, if the inhibitor attaches to the active site, there's no reaction that takes place, but it prevents the substrate from being acted on. If the enzyme is not acting on the substrates, the reaction rate is going to decrease. So you see why it's called a competitive inhibitors, because they're both competing for that same active site. It's just in one case there's a reaction, in the other case no reaction. Non-competitive inhibitors can do something similar. So if we look at the substrate and the inhibitor in this picture, they have a totally different shape. Well, that's because the inhibitor can attach to a different part of the enzyme. And when it attaches to that other part of the enzyme, it changes the shape of the active site. Now remember, enzymes are molecules, and many things can attach to these proteins. There can be other spots on the enzyme that certain molecules can attach to. We refer to that as the allosteric site. And when the inhibitor attaches to the allosteric site, the shape of the active site changes, and so now it can't react with the actual substrate. Many types of drugs act as either competitive or non-competitive inhibitors, which then makes us feel better. So what does this look like on a graph? Well, if we were to look at the normal enzyme activity, remember it goes up until it starts to level off. If we have a competitive inhibitor, it does increase rapidly at first. Eventually, all of the substrates will be reacted with. But if you take a look at the non-competitive inhibitor, notice that because it's going to attach to that allosteric site, it's going to really lower the rates of chemical reactions. So those are some factors that can affect the enzyme activity, and I'll see you in class.